Hello everyone, welcome back to the channel. It's been 2 weeks, I believe, since my last video, but I'm back with another one, and this time featuring a game that I've been spending some time playing called FortheKingdom. It's on Onchain testnet, and it uses a this open source framework by Lattice called Mud. And it's a way for, it's a way for on-chain games to have the data on chain essentially. So yeah, it has been very interesting trying to understand the data that is emitted from this game, and yeah, I've not fully completed decoding everything because there's too many, but I think I've done enough so that I can share with you all how you can go about decoding it. Okay, so let's dive right into it. So one thing I like about this game is also everything's open source, so you can see all of their stuff on GitHub essentially. Okay, so let's dive right into it. Also, before we start, I just want to say that I have no idea what I'm going to say in this video. Don't really have it planned, but just excited to try to show some of these things as to the best of my knowledge. Okay, cool. So let's get started. Man, where do I even begin? Okay, maybe let's look at one transaction. So on the game, how normal event logs work is, let's say on Lido, for example, right? You deposit ETH, and then you get sent some sort of SDETH, right, in return. And so maybe the logs would then tell you, you deposit ETH, then there's a token transfer of you receiving the SDETH in return, right? So those are the regular event logs that are emitted. But in FortheKingdoms, because they use the MUD framework, that's MUD, it only emits 2 events, and these 2 events are called store set record, and the other one being store splice static data. Okay, it's only these 2 events. Okay, and how this works is that all of the data is stored on chain like a database. So whenever there are these 2 events that are being emitted, there is an identifier in the argument that tells the contract exactly where in the storage to update, and so it updates pretty efficiently, I would say. And yeah, you don't really have to deal with many events. I guess the downside here is that it is not the standard logic that we would use when decoding events. Right, standard logic would be all the event names would be there would be different event names for different types of actions. But in this case, there are only 2 events, so we need a way to identify how it's different. And spoiler alert, the way to identify it's by the first parameter in both events, right? They call it argument 0. This means it has no names, I think. I guess the name is argument 0. And so this hex over here is the identifier. And the first thing you should notice is that this hex looks suspicious because, well, it has some sort of hex in front, followed by a bunch of zeros, and then some hex data again. So what could this be, right? So the first instinct I did is, can I split this and try to decode this? But there was no indicator on where to split. Because this is bytes 32, maybe they take first 32 characters to be something, the next 32 characters to be something, which means we can just take this whole thing and convert it to a string. So let's do that. So copy this thing, convert it to a string. I have it over here already. And remember to remove the 0x in front because that is not relevant. And after converting, we can see that it decodes to TB app PVE. Now, if you play the game, PVE would make sense because there is PVE content. But what is TB app? I don't know, but I'm assuming it means TB stands for table, right? Maybe it's like table app. So there's some sort of table that it is referencing. And indeed, there is a table. And all this table can actually be mapped back to, where is it? This one. Back to their GitHub. So for example, I'm in a GitHub, there's a folder called tables, and there's a bunch of files here organized by the categories. And if you click on one file, let's say like battle table, all these are the how on-chain data is stored essentially. But instead of this being one event, everything is either the store static data or the set record event, right? And all this information is then packed into the topic. Is packed into the data field of event logs. So we decoded it to be PVE. So I'm going to show you where PVE is. Just search, and there you have it, PVE, right? And so whatever we saw over here, right, this later portion of the bytes, this represents PVE. So this is telling me, or this is telling the contract when this data is posted on chain, update this PVE table on chain. Okay, and all this stuff can be directly related to all of the stuff here. So you have things like character ID, monster ID, right? The challenge here is then understanding how these are packed into the data field, because it doesn't follow your standard ABI encoding, because this is not ABI, right? This is like some sort of customized database inside the whatever storage. So that's the hard part of trying to do that guesswork over there. Okay, but let's move on, right? Another thing to notice is that all of because all these are essentially just two events, right? Store set record and also store splice static data. The parameter type remains the same, right? No matter, let's say in PVE there's so many all these variables, and then you take another example, PVE battle counter. There's only one this key value pair here, right? Compared to PVE. So how does all this sort of map back to here, right? There has to be a special way to do it because all of these data types remain the same, right? But okay, let's first try to get the high level picture first. So the first thing, so I'm trying to map this PVE section. Let me see. I don't think PVE is a good idea to start. Let's see if there's a easy example. Okay, this looks easy. There is only like a few stuff here. And so same thing, I'm going to copy this, paste it into hex to string. And this is character battle. Okay, so I'm looking for a table that tells me it's a character battle. So just search character battle. There you go. You have character ID, last PvP ID, PvP last attack time, last defense time, PvE last attack time. Okay, interesting. Right. So the first thing you see is character ID. So let's try to find where is character ID. Well, character ID is according to the order of operations, character ID is the first, or I guess the next in line after argument 0. And because it is index false, which means this falls under data and not topics, and so the first thing in data would be the character ID, and this turns out to be the token ID. So if you convert this from hex to int, this is just the token ID of the NFT. So how it works is that whenever you create a character for the game, you are it essentially mints an NFT for you, which is the character itself, and they use the token ID of the character for as the unique identifier for the character. So this is token ID or character ID, right? Okay, but I guess what's interesting to note here is that this is bytes 32 with a dynamic array. What does that mean? It means there can be multiple bytes 32. I mean, it just means there can be multiple elements in this bytes 32 array, and we don't know exactly how many elements are there. So this is like a dynamic array, and because it is dynamic, we should expect some offsets. So expect some offsets, a bunch of zeros, right, a bunch of 6, blah 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 blah. If you've watched my traces video, you would know how to do this. But essentially, it tells you what is the offset, how many elements are there in the array, and then finally it points to you what the actual piece of information is, which you would then convert to hex to int. But this browser nicely formats it for you. But we'll go into how we can do this manually as well. Okay, and then the next argument we see is a uint48. Okay, again this is fixed because of this event name, so this doesn't change. uint48 96. Like, why is it 96? So let's see what other information are there in the table. So the table is character ID, and we have like 4 more variables to go through, right? Last PvP ID, PvP attack, last attack time, right? All these are uint256. So how the hell are we supposed to get all this information here? Am I looking at the right event? Character battle, yeah, that's right. Character battle, yeah. Oops. Okay, interesting. So yeah, let's look at the raw data then. Okay, so I'm gonna copy this transaction, go to my query. I did written out some query here, right? Yeah, vx hash is this, and yeah, let's start from fresh. Select from raw, where event index is 8. Okay, so ideally you should be using topic 1, topic 0 to filter, but I already filtered by transaction hash, so it's whatever. Oh, what's this? This is a different. Oh, sorry, it should be 9. There you go. Event index 9. Oops. Okay. Alright, so character battle. Now I'm doubting if this is the right table. Is it this table? Nope. So it has to be this one, right? There's only one. Okay. Anyway, let's try. Okay. So topic 0 again refers to this event. Topic 1 is the identifier, and then there's no more topics. And then we go straight to the data. So I like to just copy this. So this is already segmented to 64 characters long. Copy this, paste into our JSON beautifier. Okay, so let's see what this means. The first thing we want is character ID, right? So character ID. And character ID, if we go back to the event, the first one is a bytes32 dynamic array, which means the first one is the offset for the dynamic array. So 60 convert 60 to from hex to int. 96 divided by 32 is 3. So we have to skip 3 lines. So 1, 2, 3, skip. The next line, because this is a dynamic array, the next line tells us how many elements are there in the array. Convert this from hex to int. This is 1. So it tells us that there's only 1. Okay, and this is a common pattern you will see for this, because there will only be 1. And finally, the next line is the hex for the token ID. Okay, so that's done. We already know character ID. Character ID is the 5th element, right? 1, 2, 3, 4, 5. Okay, what's next? Let's go back to our transaction again and see the data type. uint48. uint48. Now, I guess something to note here is that the 48 here means 48 bits. And converting, wait, let me see if I have this right. 48 bits means you need to divide by 8, which would be 6 bytes. Okay, so 6 bytes is 12 characters long. So the next thing here, take the 12 characters and it'll tell you this argument 2 is uint48. And the way you do that is you would take from, I mean, looking at this, it tells me it takes from the right, but there's, yeah, okay, let's take from the right then. So 12 characters long, yeah, let's do 4, 6, 2, 4, 6, 8, 10, 12, right? All this is just a bunch of zeros. So 60 convert hex to int, you get 96, which is why we see here as 96. Okay, cool. So 96 refers to what? Refers to the last PvP ID. Okay. Yeah, which is funny because here it's 256, which means it should take the full 64 characters long, or 32 bytes, right? But whatever. Okay, the next thing, PvP last attack time. And first we get to go back and check. This is bytes. So to handle bytes, again, bytes is different from bytes32, which is different from bytes32 with a dynamic array. So bytes, you have an offset, and after the offset, you have it tells you the number of characters or number of bytes. So let's see. So next in line here, this would be the offset for bytes. Okay, A0 again, hex to int, A0 is 160. 160 divided by 32 is 5. So where is it? Okay, here. So skip 5 lines is what it's telling me. So 1, 2, 3, 4, 5. Skip. We start off with the next line, and the next line is hex. You convert this to hex to int. So 20. This is 32 bytes. And 32 bytes times 2 means 64 characters. And so this, what this is telling me is that all this is the, all this is needed essentially to decode this, which is weird because there are 3 things here. So I am assuming I'm just assuming that if any of this is 0, it won't show up, right? Which is weird. Yeah, we can convert this from hex to int, and then timestamp convert this from 2 timestamp. But okay, what did we learn here? You can see that it is very different from the regular decoding, right? There is no ABI. We have to base everything off of the knowledge of using offsets, of dealing with these different data types, and referring it back to the tables essentially, right? And then the tables itself can have like, this fixed element arrays, which is challenging to decode as well. Okay. Not very hopeful, but you can see this is my work in the sheet that I was using to do some stuff essentially. Okay, enough about this. Let's look at some interesting things. Let's see, what do I have? So I have character name. Nothing too fancy. Yeah, we can try character name as well. Let's see. I do want the part, so okay, first step is getting the transaction and to look at what event indexes it. So do I have the transaction hash here? I do not. Oh my goodness. Character name. Okay, we'll do character name, and then we'll do. Let's see what's. I guess I can briefly run through the PPE stuff, or maybe PVE extra. That'll be fun. Okay, so character name, this transaction. Let's see. And then this is telling me event index 32. So let's wait for this to run. In the meantime, let's paste this one to here. Okay, you can see it's the same length. It's taking some time to run, or load, I should say. Let's find it in our table. So character name would be character tables, and then character name would be this one over here. So you have name hash and the owner. 32. This one. Okay, cool. So again, same thing. Argument 0 is the identifier. So convert this, you get character name, like TB something, and then character name. And the first one is a byte 32. So byte 32, you have the offset. So 60, like we just did, 60 converts to 96, which means skip 3. So 1, 2, 3. The next one would be, what was it? The number of elements in the array. In this case, is 1. So the next line, this is whatever the thing is. So in this case, it is a name hash. So this is the name hash. I'm not sure if I can convert this. Oh, I can. So I think this first two is the length, maybe. Yeah, I guess the name is Fakaro. And then what's next? The next thing in here is 0. So owner 256. Another thing I'm noticing is that sometimes if there's not enough things in the schema, like in this case there's only name hash and owner, the framework would sort of skip the argument. In this case it's just blank, and so that's why you see here it's blank. But then the element number 3, which is bytes, will have something. So bytes will be A0 converted to int. 160 means skip 5. So skip 5 will end up here. And this is the length of the length of the bytes, which is, convert this to hexain, 32 times 2, 64. So convert this from hex to int, gives you 11069, which is, if we go back to the table, the owner. What is this owner? Well, it refers to the token ID, the token ID of the NFT. So it's linking the token ID to the name of the character, essentially. Okay, so essentially how to decode is a bunch of going back and forth between looking at what the data type is, looking at what on GitHub, what is the schema like, and looking at the actual data itself to sort of inform you. Okay. Yeah, and then I guess for the last thing I want to show is maybe this one, TB PVE extra. So let's try that. And then let me search PVE extra. I think it's battle. Yeah, this one over here. So you have PvP ID, character levels. Wait, is this right? No, this is PvP. I want PvE extra. Oh, there you go. So you have uint, just character ID, item amount. Essentially, when you do a PvE, like you fight monsters, you get items, and the items are each unique item is assigned a particular number, and you can find these items in their data on GitHub. We'll go through that in a bit. So let's try to first decode PVE extra first. So okay, PVE extra, I don't have the transaction hash, but okay, this is decoded nicely. All of the stuff, like how to decode is exactly like what I just mentioned for the character name. So let's look at what these items represent first, right? So item ID 18. Okay, item ID 18, let's take a note of that. Now let's go back to the GitHub. And on GitHub, there is a folder called data config. And in this data config, there are items, monsters, which is like, tells you what is the monster name, what skills, ID, right? And then it also has essentially a JSON file of all of the items and their ID and description, the tiers, right, so on and so forth. And you can actually search what item 18 means. Item 18 is sticky mucus, which is a pretty common drop from killing slimes. So so because this is all JSON files, you can actually live query this into Flipside. So you can click on this raw button over here, and it will, go to this. It'll give you the JSON thing, which you can then live query. So copy this link, and that's live query. So live query .live. It's as simple as that. And you have all of the data. There you go, right? So now you can sort of flatten this data, right? Flatten the items, then join in the name of the item, and you join it on the item ID, right? So yeah, essentially that's how this MUD framework works for on-chain games. Very interesting way of storing data, essentially. And yeah, there are a lot more things that I don't exactly know. Just to give you an example, on top of the how data is stored, there are also regular functions like crafting, right? This is this emits in traces essentially, right? It tells you the craft item function, and then you can sort of figure out the KCAG of this to find it on traces and decode it like you normally would. Essentially, this is the ABI, right? So you can decode this like you normally would. And then the other thing that I don't really know yet fully is for things like this, where you can see how they sort of pack everything together. I briefly touched on this, but uint256 means it takes up the entire space of 32 bytes, because 256 divided by 8 is 32. And so if it takes up the entire space and it has 5 of them, that means there are 5 lines of it. But if it does not take up the entire space, like uint32, 32 divided by 8 is 4, so this takes up 4 bytes, which is 8 characters long, and there are 11 of it, so it's all sort of like packed together one after another, right? So 4 bytes, 4 bytes, 4 bytes, 11 times, and all those would represent damages. And then you have the same thing for HP, 4 bytes 2 times, right? And all these are sort of like, again, tightly packed. I have this actually decoded over here, PVE, but I'm not so certain of other events that has similar data packing, because I'm not sure yet how exactly this works. But yeah, this is what it looks like essentially. See how it says here, cutting it by 64 characters long, so this is the uint256, and then cutting it by 8 characters long, that is the uint32. Yeah, I think that is all I have to share in terms of decoding. If you play the game, I made a dashboard, which is just pulling from GitHub. What is essentially what items are dropped by what mob. So let's say you're looking for a specific drop, you can search the item name here, and it'll tell you what mob drops that item. Yeah, and yeah, looking to put this all in the dashboard as well. But yeah, I think that's all I have to share in this video. I really enjoy the data that this game emits, or the MUD framework I should say. Really interesting stuff, and yeah, thanks for watching. If you made it all the way here, thank you, and I'll see you all in the next one. Bye.